Basically, this is a revision for P3 questions, okay? So if you find yourself when you were doing the questions, you are struggling, it basically means that you need to revise your P3 topics again. All right. I know I have some new students, okay? So not new students, those that came for trial lesson last week, you all are now permanent students. So for Chloe, Li Wen, Anita, and Lucas, okay, I want you all to stay back after class just for about 5 minutes. I want to ask you all what are the topics that you feel you are weak in, and I will, if I have the notes, I will send it over to you. Okay, so we will do that at the end of class for 5 minutes. I will remind you all again. Okay, so without further ado, I'm going to jump into lesson. Viola, just to let you know, I noticed that you attempted the questions twice, right? I am going to just take the readings from the first attempt. Okay? Can? Okay, so first question is a question on, actually, I wanted to do a revision on magnets before we, okay, let's skip the first question first. I want to start on a quick revision on the topic of magnets. My advice is those who have paper with you, if not, go and get some paper and writing material so that you copy down, okay, the relevant notes that I'm going to write on the screen. All right. So I know that you all will get access to the slides later, okay? But writing it down actually helps you remember better. So I advise you to copy it down. Okay, when we talk about magnets, there are a few how do I say it? There are a few important things about magnets that we need to know. Okay? First and foremost, we need to know that if we look at a magnet, magnets can come in all shapes and sizes. Okay? The common ones will be a bar magnet. We also have something like this. This is a rod magnet, ROD. We have a horseshoe-shaped magnet. I'm sure you all have seen this before. We also have a circle magnet. All right. The most important thing about magnets you all should know by now is magnets have two parts to it. These things that I'm drawing, okay? Chloe, what do I call them? These things that I drew in red, what do I call them?
North and South Pole.
Okay, so all magnets have two poles. Okay, the poles are at the ends of the magnets, okay? We have the North Pole and the South Pole. So please remember in your exam, if the examiner asks you to name what pole of the magnet it is, you need to spell it out. You cannot just write N and S. All right, a lot of y'all made that mistake in your homework. So please, if you are asked to spell out or name the pole of the magnet, you need to spell it out in full. Kyla, do you understand? Liwan, do you understand? Okay, so spell it out. Okay, the next thing. Viola, can all materials be made into magnets? Or can are magnets made of any material?
No.
Yes or no?
No.
I can't hear you speak. Can you speak up?
No.
So only what materials can be made into magnets? Viola. There are four materials that can be made into magnets. So what are the four materials? Viola, can you let me know?
Iron, steel, copper, and
Are you sure it's copper or not? Do you remember what's the last one, Viola? Do you remember or you do not remember? Okay, you better copy down, yeah? Lilin, can you help her? What is the one that starts with C?
cobalt.
Cobalt. Very good. Now, it's not just Viola that makes this mistake. A lot of people think that it's copper. Please do not make this mistake. It is cobalt. Okay, what is the next one? Li Wen, the last material, the last magnetic material. Also cannot remember. Starts with N. Can you remember? Cannot. Li Wen cannot. Lucas, can you help her? Lucas, sorry.
Nickel.
Good. Those who cannot remember, please write it down. Those who can remember, also write it down. Kyla, please copy, yeah? So these are known as, Anita, what do I call these four materials?
Magnetizable.
No. Mag what?
Um,
Magnetic materials.
oh.
Okay, so only magnetic materials can be made into magnets, and only magnetic materials. Tyler, what happens if I put a magnet near a magnetic material?
The magnet will attract the magnetic material.
So take note of the word that I want to hear. Magnetic materials are attracted by or attracted to magnets. Okay, so Kaden, when I talk about attract, is it a pulling force or a pushing force? Sorry, louder, the class can't hear you.
Pulling force.
Pulling force, very good. They will come together. Okay? So please remember, magnetic materials are attracted to magnets. Now, magnets can exert a pull or a push. Okay, so these are the two options, okay, that a magnet can, that you will see if you put a magnet next to some materials. So as what Kaden said just now, when I talk about a pull, it is an act of attraction. Okay, I repeat, the pulling force is known as attraction. Janelle, the pushing force, what do I call it? Starts with R.
Repel.
Repulsion or repel.
Yeah.
Very good. So it's pushing away. So there are two occasions, okay, in which a magnet exerts an attraction, a force of attraction. Magnets exert a force of attraction when they are placed next to a magnetic material. All right, so when I have a steel bar next to a magnet, it will attract. When I have an iron nail next to a magnet, it will attract. There is another occasion, there is another instance where you will see magnets attracting something else. What is that instance, Brian? When else will I see magnet attracting something else?
Magnets attracting unlike poles.
Very good. So unlike poles of what? Another?
Magnets.
Good. So I will also see magnet attracting unlike poles of another magnet. Very good, Brian. So what does this mean? If you all want to draw it out, you can. If I have magnet A here, If this is the North Pole, this is the South Pole, I have magnet B. What pole will this be, Raphael? For
South.
attraction.
South.
Very good. Raphael, please copy all this down, yeah? Luca, are you there? You're copying? Okay, good. Now, Luca, can I ask you, when does magnets exert a pushing or a repelling force?
The light pole.
Of what? Light pole of another?
Another magnet.
Yes, you have to say of another magnet, yeah? So everybody, please take note. What Luca is saying is, if we happen to have magnet X and magnet Y moving away from each other, all right? Viola, can you tell me what pole is this of magnet Y? They are moving away. Janelle, please pay attention.
South.
Good. Like poles. So similar poles. All right, very good. Okay, the next one, I have actually two more, so I'm going to try and find some space. I'm going to squeeze a bit. Magnetic force can only pass through Okay, Sky, I want you to fill in the blank for me. What is the word in the blank? Magnetic force can only pass through what?
Magnetic materials.
Oh, Sky says magnetic force can only pass through magnetic materials. Raphael, is he correct?
Wait. No. Non-magnetic
So what should the
materials.
correct answer be? Raphael?
Non-magnetic.
Very good. Non-magnetic materials. So please remember this, guys. If I were to have two setups and I have paper clips inside and a magnet, okay, if I see attraction, all right, this material has to be non-magnetic for the magnet to attract the paper clip. If I don't see any interaction, as you see in the other setup, it means that the container is likely to be made out of a magnetic material. So it will block the magnetic force of attraction from the magnet. Anita, do you understand? Is it okay? V1, are we okay so far? Good. Tegan, okay? Janelle, please copy, yeah? Okay, yes, Tegan?
I think you labeled it wrongly because for the non-magnetic, you showed the magnet attracting the ball.
Yeah, what's wrong with that? Magnetic force, Tegan, can only pass through non-magnetic materials. Correct, Tegan? So let's say setup A on the left.